Hello, Amit. Hello, Ankit, can you hear me? Hello, am I audible to you? Ankit, hello, this is Manjeet, and I am in the research scholar in the Department of Physics of the Indian Institute of Technology in Roorkee, and I'm here for the PMRFTA SIP for the course of Nature and the Properties of the Materials, which is taught by the Professor Ashish Garg. Can you mute it? I mean, Ankit, तुम्हें आवाज आ रही है? You can message it. I mean, yeah. So, should we start? I mean, it should be the kind of the discussion time. It should be the one-to-one discussion. So please, reply. I mean, if should we start it? You can message it if there is background noise in your from your side. Ankit, can you hear me? Just let me know only. Am I audible to you? Okay. Okay. If you face any kind of the difficulty anywhere in the assessment tutorial session, this session, please let me know. Is if any kind of the problem when you face it, I mean, okay, just a message in the I will check it and stop me there if you have any kind of the doubt also. Okay, shall we start? Is it my screen visible to you now? Okay, so let's start the assignment. Okay, so our first question is which of the following has or have the non-crystalline structure? So these are the multiple choice question in which where are the one or multiple option will be the correct one and you have to select it which one is the correct. Okay, so let's start with the question number first, uh, which is the following have has the non-crystalline structure. Option are iron, quartz, silica glass, and the window glass. So, do you know about the crystalline and the non-crystalline structure? Sorry, can you type? I mean. because your voice is not I mean audible. So if it is possible, then please write in the chat box. I will check from here. Ankit, please mute yourself and message in the chat box. Okay, from I don't think so. Is there an issue from your side, or should I mute you? Okay, shall we start the question number first? There is so much background noise from your side, so please mute yourself. Yeah, now it is fine. So let's start the question number one. So here it is. Which of the following, however, has the non-crystalline structure? So professor has also taught you about the non-crystalline and the crystalline structure, where we know that the crystalline structure has the periodic arrangement of the atoms and non-crystalline has the non-periodic arrangement of the atoms. Why? And we call it also the random arrangement also. Crystalline have the same symmetry in the every direction, while the non-crystalline structure has are I mean not symmetric to the every directions. So they have they are long crystalline have the long range and these are the short range because they are symmetric to the every direction. So they have the high melting point and they have the low melting point. Okay, so in this question, they have asked about the crystalline non-crystalline. Which of the following has the non-crystalline structure? Iron, quartz, and the silica glass, and the window and glass. You all know that the glass are the non-crystalline, or we can say this is the amorphous material. So So according to iron is the crystalline one. Mostly the materials are the crystalline. Mostly, not all the materials, but the mostly materials are the crystalline. So elements, all the elements are the crystalline. So the iron and the quartz are the crystalline, while the silica glass and the window glass are the non-crystalline nature. So for the first question, C and D will be the right answer. Okay. Do you have any doubt in this one? Ankit, do you have any doubt regarding this? Okay. Uh, I'm assuming that you don't have any doubt. So let's move to the question number two. So, uh, which of the following is a characteristic of the crystalline structure. Again, this question also belongs to the crystallinity of the structure. So here it is asked about the characteristic of the crystalline structure. There in the first question I told you about the a few properties of the crystalline nature. So here also they have asked about the density, melting point, and the structure. So if I'm compare with the non-crystalline and the crystalline structure with their properties, if I'm talking about the density, because these they have the random non-crystalline have the random arrangement of the atom, so they have the low density, while crystalline material have the regular pattern. I mean, if I draw the this crystalline structure will be the regular pattern, and non-crystalline will be this kind. There is no regular pattern, non-periodic or the periodic one, you can say. So in term of the density, they have non-crystalline have the low density and the crystalline have the high density. Next property they have asked about the melting point, because they have the high density. So and the force are also the long rays, because in any direction they have the same pattern. So melting point should be the high for this one, the crystalline one. So they have the high melting point, and the non-crystalline will be have the low melting point compared to the crystalline structure. They have the variable range of the melting points. I mean, because it's depend upon the materials how they are arranged, so there is no fixed melting point there, because they have the random arrangement of elements. Some have the high melting point, some have the low melting point. Generally, non-crystalline have the low melting point than the crystalline, and the crystalline have the high melting point. Now the very about the structure, they have the fixed structure, crystalline, because their structure is defined, and here there is no structure is defined, they have the varying structure. So in this question they have asked the characteristic of the crystalline structure. So we have discussed about the crystalline and the non-crystalline characteristic. Can you tell me the which option will be the correct for this one? Okay, high density. Yeah, correct, you are correct, this one with the high density one. Okay, let's move to the question number 3. This one is about the symmetry. Symmetry. So now we have talked about the crystalline and the non-crystalline. In the crystalline structure, we have the different kind of the symmetry, where one is the cubic. There, one of them are, I mean, few of them are the cubic, hexagonal, triclinic, tetragonal, and the few are there. So if I'm talk about the cubic, let's discuss the one by one this structure, and then we will find out the which one is the highest metric one. The cubic has the, if I'm taking, because these are the three-dimensional crystalline structure, so cubic has the A equal to B equals to C, and where alpha equals to beta equals to gamma equals to 90 degree. Okay, in the hexagonal, cubic is basically the cube one. If I draw this one, okay, the hexagonal, in the hexagonal your A is equals to B but not equal to C, and your alpha equals to beta, beta equals 90 degree, and the your gamma is equals to 120 degree. Here the hexagonal is of this shape, this one. These are the atoms here, and the same also there will be the atoms at the lower part also. If I draw this one, Actually, I am not good in drawing, so you have to bear with me this thing. It will be such something like this one. This is the hexagonal one. This one will be the hexagonal. You can see from here. This is also the same hexagonal structure here. Here we have, this is my A and this is my B, or this is my B, and this length is my C. So you can see, because this is the hexagonal, all the side of the hexagonal are equal. So my A and B are equal, but C is not equal to A and B. And here also my A, alpha and beta also 90 degree, because this angle alpha, also this is my beta, this is the angle, these alpha and beta are 90 degree, but gamma, the angle between these A and B, the hexagon, the if I'm looking at the gamma will be the angle between my B and C. So this is the gamma will be the my angle between A and B. So this is my A and this is B. Here the my atoms are arranged at the corner of the hexagonal one. So this is my gamma, and this angle, because we know from the, if we have the hexagonal, six side of the hexagonal, then and the total sum of the angle inside will be the 360, and this angle will be the, because all the sides are equal, this angle will be the 360 divided by 6, so 120 degree. So this gamma will be the 120 degree. Okay, and then we have the triclinic one. Triclinic is basically where my A is not equals to B and B is not equal to C, even my A is not equal to C, and alpha also, alpha, beta and gamma all are not equals to the 90 degree. So this is the so random. This triclinic is the one of the most unsymmetric structure of the, if I'm told, this is will be the something, I mean, all are not equals to. Now we have the another one, we have the tetragonal. In tetragon, it is similar to the hexagonal, but there is slight difference between in this tetragonal. We have the A equals to B, but B is not equals to C. This is my tetragonal. And my here my alpha equals to beta equals to gamma equals to 90. All angles are equal. So if this is my A and this is my B and this is my C, so A and B are equals and the C is not equals. So this is the my tetragonal structure, because this layer is at perpendicular to this plane is completely perpendicular. These both planes are the parallel, and this plane A and C, this is perpendicular to this one. So my angle alpha, beta and gamma all are the 90 degree. So from these four one, you can find out the which structure has the unit cell has the highest symmetry. Can you tell me which one will be the highest symmetry? In the cubic, A equal to B equal to C, and all the angles are the 90 degree. In the hexagonal, A equal to B but not equal to C, and the alpha equal to beta, that is equal to 90 degree, but gamma is the 120 degree. In the triclinic one, no, not even is the side and the angles are equals, and angles are also not equals to the 90 degree. In the tetragonal one, A equals to B and but not equal to C, and alpha equal to beta, beta equals to gamma equals to the 90 degree. So can you tell me which unit cell has the highest symmetry? Cubic, hexagonal? Can you see my screen proper? I mean, So Ankit, can you tell me the which unit cell has the highest symmetry? Cubic, hexagonal, triclinic, tetragonal. Cubic has the highest symmetry because here the all the sides are equals and the all the angles are equals to the 90 degree. So this set has the highest symmetry. Okay, in the hexagonal here the B is not equals to C, but in here the all the sides are equals. In the triclinic, no, none of the sides are the equals. Okay, so let's move to the question number 4. Ankit, do you have any question regarding the question number 3, 2, 1? Okay, okay, fine. Okay, so next question is one of the characteristic properties of the polymeric materials as compared to the metal. So you have to tell me what is the characteristic property of the polymeric material as compared to the metals. You know about the metals, you know about the polymeric materials, so you have to tell me so which of the characteristic properties of the polymeric material as compared to the metal one. You know about the metal and the polymeric materials. So if I remember, polymeric has the soft and the light one, and they can be stretched. I mean, the bonding in that one be the in between. If I'm talking about the one layer, they have the covalent bonding, and the in between the layers, they have the van der Waal bonding. I am assuming that you have done this in your course one also. So can you tell me the which one property will have the polymeric material compared to the metallic one? If which one has the higher temperature stability, metallic or the polymeric? Polymer basically. Polymer or the metal one? Met Polymer are basically the low temperature stable. They are kind of they does not stabilize at the higher temperature, so they metal have the higher temperature stability, and the also metal have the higher mechanical strength. uh, they are the metals are my ductile also, and the higher elongation, I mean, and the lower hardness. Polymer are basically my soft and the light, and they can also stretch to a long distance, and they are not good for the high temperature, so that's why they have the low temperature stability and the higher elongation, and the this one is the soft one also compared to this the metal one, so they have the higher elongation, which we call they can be stretched to up to a maximum distance without destroying their structure. So the this sorry, this one will be the for the characteristic of the will be the higher elongation. Do you have any doubt in this one? Are you getting my point? Okay, okay, okay. So, okay. Now this is the a simple question. So you have to tell me, figure out the incorrect statement about the ceramics in the following. So, uh, so first tell me the few characteristic of the ceramic, if you can remember from your class. Any property of the ceramic that you can recall? No? Okay. Ceramic are basically brittle, They are strong, they are low electrical conductivity, they are having the low electrical conductivity, they have the low thermal conductivity, and also they are having low thermal expansion. So here we have to find out the incorrect statement here. So if I'm counting the, are they good insulator of heat and electricity? Because they are the low electric and thermal conductivity here, so they are the good insulator of the heat and usually harder than the metals. Yes, ceramic have the harder than the metals. And are they ductile in nature? Ductile, I mean, can we, are they? No, they are not ductile in the nature. Ceramic are not. We can't elongate the ceramic materials into the, we can't deform into the wires. This one. So the ceramics are not ductile in the nature. So here we have this question has asked about the incorrect statement. So you have to find out the fourth statement about the ceramic one. So the ceramics are not ductile in the nature, so the appropriate answer will be the ductile in nature. Ceramic also contain the metallic and the non-metallic. If I'm talking about the ceramic, can you tell me the few example of the ceramic, if you can remember? Ceramic, any example, I mean whatever the glass you are holding in the, I mean mug, mitti wala, and kind of this one ceramic, all, or because all are of the ceramics. So these are the ceramic, they also contain the metallic and the non-metallic compounds. So let's examine, this is the alumina, Al2O3, silicon carbide, all are the example of the ceramic one. So ceramic are the good insulator, these the good insulator of heat and electricity, and they are usually harder than the metals also, and they also contain the metallic and the non-metallic ions. So the wrong point about the ceramic is that they are in ductile in nature. No, they are not ductile in nature. So the correct statement will be the C part. Okay. So let's move to the next question, which is this one. So which of the following could be defined as a microstructure? Cross section of a stem of a tree, pores in the fiber, atoms in a materials, and the grains in a materials. So you have to tell me which one is the macrostructure. देखो, structure, basically we have the four type of the structure. One will be the macrostructure, another will be the microstructure, and then my uh, atomic structure or the nanostructure. So this can be visible to our eyes, and these are not visible to us. We have to, if we have to see these kind of the structure, we have to go through the optical instrument, TAM-SAM. And for this atomic, if we have to go through the go up to the atomic level, then we have to use the simulation sum to check that one. Okay, so here they have we have to tell me, so we have to they have asked about the microstructure, the whatever the segment is here, so are they visible to our cross section of a stem of a tree? Can we see that one? Cross section of a stem of a tree, or the pores in a fiber, atoms in a materials, grains in a material. Can we see the grain in a material with our eyes? No, because see, if I'm holding this pen is also material of a any material. So this material source also having the atoms, and they have the grains and green boundary. I can't see this grains in the material, in this material with my eyes. I need the same motif for to see the grains in the material. So we can't see the grains with our eyes, and the atoms in a material also we can't see the atoms. We need the uh, atomic for the atomic level. If we have to go to the nuclear level, then we need the simulation kind of things. And the cross section of a stem of a, see how we can easily can see the cross section of a stem of a tree and the pore in a fiber. If we have given any kind of the clause, then we can find out the here it is okay, this is the pores in the my fabric. If somebody has given you the woolen clothes, and you can find out this is the poor one, you can easily find out that. But if we talk about the atoms and the green in the material that we can't see with our eyes, so these are not in the microstructure. The microstructure will include the cross section of a stem of a tree and the pores in a fiber. Can you tell me the any other example of the microstructure? Any example, I mean. Whatever thing that are visible to our eyes, that will count in the microstructure. Okay, do you have any doubt till this point? Do you have any doubt? Okay, uh, let's move to the another question. Next question, this is a question number 7. So at the equilibrium separation between the atoms, which of the condition is fulfilled? The bond energy is minimum, potential energy is minimum, force is attractive, and net force is 0. So if you remember this graph, we have different force. If I'm talking about the atomic level, so we have this graph. This one is the repulsive one, and the attractive one, this will be the, if we have the two atoms and they are bind with some energy, and they have the net bond energy, a bond length will the R minimum. So if they are existing at this level, means they are not having any kind of force here. The force net will be the 0. Here the my attraction, because both have the both the atoms has the some charge or something else, they can be have the attraction and repulsion force here. But at this certain this length equilibrium and separation, if I go, R minimum will be the my equilibrium separation. So at this point, if I'm draw the net force, so it will be the something here. Okay, here this is my R minimum, because here my the repulsion, my attractive force will be the negative one, and my positive will be the repulsion force, this one. And if you can recall, this is basically F. Net will be the attraction will be the, I guess, Z E1 E2 by R square, and the repulsion will be the B R is to power M. So this part is my attractive force, and this is my repulsive force. And at R minimum, this force, if you can see from this graph, we have this force with the plot of force with the resistance, and here I can see this is the force is my 0. If this is my y-axis, this is my x-axis, and at this point my force is 0. So if I equate this and find out the R, that will be the my R minimum, or we can say this is the my equilibrium separation that gives the stability to that atom, that bond. I mean stability to the atoms or the bond. So that's why they are exist in that structure. So this is my the R minimum. And if I'm corresponding to this plot, if I'm plot the so this is giving me R will be the, if I put equals to 0, so that will give me the R equals to R min, and corresponding if I plot the energy plot here for this, if because the force is 0, so the my this energy will be the minimum at this point, so this will be the minimum at the R minimum at this point. This is my R minimum, the distance that is R minimum. This is the potential energy with respect to R, and this energy is my the bond energy. Okay, so here they have asked about at the equilibrium separation. This is my R minimum is the my equilibrium separation between the atom. Which of the which of the condition is fulfilled? First one is the bond energy is minimum. Here the bond energy is the minimum. Is it true? Or the potential energy is the minimum. This is graph is the potential energy versus atomic distance, interatomic distance, or we can say interatomic distance. So here the my potential energy at R potential energy is my minimum value. Note the my bond energy is minimum. Okay, is the force is attractive here? No, there is no force is existing at this point. There is no repulsion. There is no attraction force existing at this point. So there is no force. Net force is 0 and the potential energy is minimum. So is the my bond energy is maximum at R minimum. The my bond energy is maximum or the minimum one? Because this is the bond energy. This amount of the energy that is holding the my atoms together, so it is the maximum or the minimum at this point. Beyond this point, this is I mean, if I go at particular distance, this force might becoming then the repulsion, and here after this point my force is becoming like the attractive one. Because if we hold something, there is a, when we talk about the two atoms are separate apart, so here when they are attracting when they are apart they are attracting each other, and when they are come closer at the certain point they have the this R minimum where they're the, because two more atoms are coming closer, so they have the repulsion also, because the positive and positive nucleus come into the picture and they have the positive charge, so there will be the repulsion force also. So at a certain distance they have the net force equals to 0. That net force is basic this one that we are calling it the equilibrium separation between the atoms. So for this one the my potential energy is minimum and the net force is the 0. Okay, am I clear to you? Ankit, if you have any kind of doubt, please feel free to ask any kind of question. Okay, let's move to the question number 8. So question number 8 is basically the higher coefficient of the thermal expansion of a material is generally a manifestation of strong bond, thermal vibration, weaker bond, or the low bound energy. So first tell me what is the coefficient of the thermal expansion. When there, we generally denote with this alpha. Do you know about the coefficient of thermal expansion? What is the value for the this for metal, ceramic, polymer, and the composite one? Because we have the four different type of the materials, that is metals and alloy, ceramics and glasses, polymers, and the composite one. So how we define about the coefficient of the thermal expansion? Basically, if we heat some materials and there is a change in the length of the material, so that is defined by the my coefficient of the thermal expansion. And this alpha, if I'm talking about, this is the 1 by how much my length will change, that is delta upon L change with respect to if I'm giving the temperature difference. So how is my the length of the material get changed when the temperature difference is provided to the materials? So is it kind of, if we heat the rubber, will it elongate or retain its size? So if we heat something, does it change its shape or not? Does it change its length or not? So that comes under the coefficient of the thermal expansion. So here they have asked about the higher thermal expansion. So this coefficient should be high. If they have the high thermal expansion, and there should be some, because there is something I mean the thermal expansion, so there should be the length, yes, something change in length also. So high thermal expansion lead to the, because both alpha is inversely proportional to delta T, my alpha is high, so my delta T will be low, and my delta T will be low. I mean, I am providing the low temperature difference to the material so that we can get the high coefficient of the thermal expansion. Now I have to relate this delta T, low delta T, to these condition. If we have the strong bond between the atoms, so can this low temperature difference will be the sufficient enough to, I mean, to change the length of the material, to change the, if we have a strong bond and we are giving the low temperature energy to the material, will it be the sufficient to change the length of the material? No, it will be because the strong bond, they are the strong, I mean, they need the higher energy to, I mean, to break or something, to change in their length or something. The strong bond will not lead to my delta T, low delta T. So thermal vibration, no, because we are also providing the thermal energy. Thermal vibration also, it's depend. I mean, how this is kind of thermal vibration. If I'm this low temperature will be low, it will not be enough for the thermal vibration one. So my low delta T will be, I mean the bond existing between the materials should be the weaker bond. So that if I'm giving the low thermal energy, they can easily break and can change the length of the material. So weak bond. And if they having the weak bond, so they having the lower bending energy, because the strong the bond, higher the higher the bond energy, or higher the melting and melting point, and also higher the boiling point. So the here my this weak bond, this simply implies the lower bond energy. So lower bond energy, so the low bond energy have the lower melting point or the boiling point. So the temperature difference should we need the, for to change the length of the material will be the low. So for the delta, for low delta T, the bond or bond energy should be the lower one. If we want the high thermal expansion, so temperature difference should be the low because they are the inversely proportional to the delta T, and for the delta T is basic delta T implies the weaker bonds and the low bond energy. Are you getting my point? If this question is asked about this, if we have the low coefficient of thermal expansion, so what kind of the what kind of the bond bonds are existing in the material? Take your time and just let me know what kind of the bond will exist in the material. If we have the low coefficient of thermal expansion, then what kind of the bonds are existing in the material? Please go through this expression. Now we want, instead of the high thermal expansion, we want the low coefficient of thermal expansion. And tell me the what kind of the bonds are existing in the material. Ankit, so how will you approach this problem? I mean, if somebody asks you, and this is asked in your question paper, so how will you approach this one? Any idea? See here, the coefficient of thermal expansion is inversely proportional, alpha is inversely proportional to delta T. Now this time we want low thermal expansion, low coefficient of thermal expansion. That is usually have in my metals and the ceramic also they have the low thermal of expansion, low coefficient of thermal expansion. Now we want low, this should be the low because these are having the inverse relation. I mean the opposite relation. One is high, then another will be the low one. So my delta T will be the high if we need the high temperature difference. So we have the four type of bond. Now we are having the four type of the bond and the ionic covalent. Okay, that we have mainly of two type. That is one is the primary bonds. You know about this, I guess. And one second is the secondary bonds. Primary bonds include the ionic bond, covalent bond, and the metallic bond. While the this is because of dipole moment. So this exists in the hydrogen bonding or the weak van der Waals forces. Okay, so now the where now we need the high temperature difference. So what kind of the bond they have? We need high temperature just to change the length of the material. If I'm heating and I need the higher temperature just to melt that to change the length of the material. So what kind of the bond are existing in that material? Isn't it with the strong bond? Because the strong bond have the strong bonds need the high energy. just to change their length. So if somebody asks you about the low temperature coefficient, then it will be have the strong bond. And the high temperature, if high coefficient of expansion, high coefficient of thermal expansion, then it lead to the weaker bond or the weak bond energy. Similarly here, the strong bond or the high bond energy. I hope this is clear to you. Okay, which part do you like to zoom in? Is it visible to you? No? See, this one. So this is the question. That is the assignment. In the assignment, write it down if you want to. And this is the question that I ask you. Let me, okay. Is it clear to you? Yes or no? Okay. Are you getting this point? I mean, what I am trying to clear it out, the about the low thermal low coefficient low coefficient of thermal expansion or the high, because in the question they have asked about the higher coefficient of the thermal expansion, and I ask you the lower coefficient of the thermal expansion. So higher one will lead to the weaker bond or the weak energy, and the lower will lead to the higher bond and the higher bond energy. Okay. Okay, so let's move to the next question. Question number 9. Now I'm zooming this part. Maybe it is clear to you as well. So if there are the 6 electron in the d orbital of a transition matter, the number of unpaired electron will be number of unpaired electron are. Now this question you have to tell me about it. This is so easy. I think you have done this in your 11th or 12th classroom also. So you have to tell me. So number of the unpaired electron are in the, if we have the 6 electron in the d orbital, so how many of the unpaired electron will be? 6. Yes. 6? Huh? No, there are the 6 electrons in the d orbital. Unpaired electron. Now you have to fill the 6 electron in the d orbital. And the how many will be the unpaired electron? Just fill the 6 electron in the d orbital. In 0? No, it will not be 0. Fill it in. I mean, we have the 5 orbital in d orbit. In the d orbit, if I am the 5 orbital that are my d xy, dy z, dzx, dx square minus y square, and dz square. These are the 5 suborbitals of my d orbital. And the in d orbital we have this 5. If I am this 1, 2, 3, 4, and 5. Now you have to fill the 6 electron. And you know about the Pauli exclusion principle. Now fill these 6 electron in the d orbital, this d orbital, and tell me the how many will remain the unpaired one. Okay, so there are the 6 one. So first, in according to Pauli exclusion principle, we have to first put the single electron in the single orbital. Then we have to start the pairing one. So now we have the 6 electron. Remember this one, 6 electron. Now we have to fill in the d orbital. So I'm telling, so this will be the one. I'm denoting my one electron by this one. So second, this will be the third one. This will be the fourth one. Fifth. Now we have to start again from here one. So this will be the sixth one, because because in the same element two electron do not have in the same spin. So one is in the up state and another in the down state. So I have just represented with the one will be the up one and this is the another will be the down state. So now tell me how many of the unpaired electron are. Now this is simple. I have already done the coupling one. So just tell me you have to how many of the unpaired electron are. Unpaired, which are not paired. Only this orbital is having the paired electron. So how many will be the unpaired one? See here unpaired will be the this one, this one, this one and this one. So how many are the unpaired one? So 4 electron will be my unpaired electrons. And if somebody asks you how many are the paired electron instead of unpaired, if somebody asks you the paired one, so how many of the paired one? This is only one the paired electron. These are only this one, this or d orbital are having the paired one. So this orbital only, this one orbital, one suborbital are having the paired electron one. Okay, am I right? Is it clear to you, Ankit? I'm assuming that. Okay, nice. Thank you. Okay, let's move to the next question then. Now this is the same kind of the electronic configuration one. So now nickel is, which is the question is nickel, which is to the left of the copper, that having the electronic configuration is 3d10 and 4s1. In the first transition series has the outer electron configuration. This is for the copper one. They have this outer electronic configuration. Now you have to tell me the for the nickel one. If let's see, go to the periodic table one. I have kept the periodic table here. Can you see from here? So see here, this is the copper one and this is the nickel, and they have given for the copper one, they have given as 3d what was that, 3d 10 4s1. This is the 3d10 4s1 Now this is, now you have to find out the electronic configuration for nickel one. See, atomic number of copper is 29, atomic number of nickel is will be the, because it is left two copper, so it will be the 28. Now you have to find out the electronic configuration of, this is the 29 having the atomic number 29, atomic number, and this atomic number is 28. Now we have one lesser electron in the nickel. If I compare with the copper, nickel are having the 28 electron and copper is having the 29 electron. So if I say this is the electronic configuration of copper will be the argon 3d10 4s1. So tell me the electronic configuration of, because here the 18 electron are here, 18 plus 10, 28 plus 1, 29. So 29 electron. Now nickel we have the 28 electrons. So this will be the argon. In argon state we have the 18. So what will be the 3d? How many electron will be in the d? And how many will be in the 4s1? That you have to. And the option are 3d are having the 9 1. This is 1, 8, 2, 11, 1, 10 and 2. So how many will be in the nickel one? This is having in the, this argon is having the 18 electron. So how many electron will be in the 3d and how many electron will be in the 4s1? When we fill the electron, we have the electronic configuration is like this for the transition metal. If we fill like this. This is 1s2 into s2 2 also, 2p6, then 3s2, 3p6, then 4s2, 3d, 10. These all are the filled. This one, and this is my argon. Now we have to fill the, because up to here the 18 electrons are there. Now in the nickel we have the 28 electrons and 18 are already occupied till here. Now we have to fill the only the 10 electron one. So now 10 electron will goes to, how many will go into the 4s and how many will go into the 3d? Just think, and the copper having the 29 electron, 18 electron are occupied till here, and they have to fill the 11 electrons. So they have put the 10 electron in 3d and 4s and 1 electron in the 4s orbital. See here the total number of electron are 28, and organ, up to organ they have, we have filled the 18 electron. Now the 10 are remaining. So 10 are, according to say, it should be the uh, 2 electron first, because before I mean the 4s orbital will be the filled first and the 3d later. But here we have filled, if I'm comparing the both the this electronic configuration, this is the copper one, nickel one. So for nickel we have to put the 10 electron. So 10 electron, if 2 electron will go in this one, so remaining 8 will in go this one. Okay, because the 10 electrons are are remaining just to for the nickel one. So if I'm seeking the for the copper one, this will be the argon. They have given the 3d10 and the 4s1. And in nickel will be the argon 3d8 4s2. Now you can ask why the now it isn't it should this copper should be like this one because we are feeling like this, so it should be the 4s2 3d, I mean 9 here, because for the nickel they are having the 4s2 3d8. Here why the d orbital is filled first then the 4s orbital? Because d for the stability one, if we fill the d orbital, because in these are the exception cases, otherwise we fill the 4s electron first and the d orbital later. I mean, so in this kind, for the stability purpose, so the one electron will move to the d orbital and stabilize that one, and the only one electron will remain in the 4s1. The normal, if you have this is the exception case. If you have to write the electronic configuration, so go with this one 1s2, then 2s2 again, then 2p6 3s2 3p6, then 4s instead of 4 of d. And if somewhere also when d have the, because the fully filled orbital and the half filled orbital are the more stable than the partially filled one, so generally this will become the fully filled, so that's why one electron will move from the 4s to the 3d here. But in case this will not be the fully filled or the half filled, because in the now the in d we have the, if the, because 4s will fill one, I mean 4s will be the filled first, so now 4s 2 electron already there, so if I'm counting this will be the 1 2 3 4 and 5 6 7 or 8, so 2 electrons are there. And if I'm taking this copper example, if they have the 4s, this is my 4s one and this is my 3d one, so 4s they have the this electron 1 and 2, and now earlier it should be like this one, na? D should be like it should be like this. D has the 9 electron, 1 2 3 4 5 6 7 8 or 9. Now what happened, so because this, if one electron will come here, so this will be the stable one, 3d will be the completely filled one, so one electron will move to here and this will become 4s 1 3d 10. Okay, otherwise in nickel, because this 4s2 is already stable, because two more electron are needed to be complete for the d orbitals. Okay, so here it is the 4s2 3d2, so the correct option will be the 3d8 and the 4s2. Okay, now move to the next question, that is the question number 11. So the primary bond have the energy range in kilojoule per mole. One A option is 1000 to 5000. Second is the 100 to 1000. Third is 10 to 100. And D option is 1 to 100. So which one is the correct? What will be the energy range for the primary bonds? Which which one option will be the correct one? Is the question visible now? Ankit, are you there? Okay. So can you tell me the which option is correct? If you can remember that. Okay. Not an issue. We will discuss this thing. Okay. So see first the primary bonds. Primary bonds I already told you. Primary bonds are of the three types. First, on the basis of the bond energy, we have the two type of the bonds. One is the primary bond and that is the secondary bond. Okay, because primary bond are having the higher energy, so the secondary bond, if I'm saying this is the my secondary bond energy is lower than my primary bonds. Ionic and the primary bond include three types. One is my ionic, second is my covalent, and third is my metallic. So what will be the order of my bond energy in particular? If I see in the particular ionic having the bond energy that is greater than 100 kilojoule per mole, covalent are having the energy that is 50 to 350 kilojoule per mole, and this metallic is having the 20 to 350 kilojoule per mole. So in the question they have asked about the primary bond. So primary bond is the sum of the ore. So what are they having the energy? Is it they are lying to the thousand range, 1000 to 5000? No, because they are having in the greater than 100, 50 to 30, and this one. Are they lying in 10 to 100? No, they are not, because ionic bond having the greater than 100 one. Are they lying into 1 to 10 energy range? No, these are also not. So the correct answer is the 100 to the 1000. And this secondary bond having the bond energy lesser than the 100 kilojoule per mole. Okay, so the correct answer will be the 100 to 1000 kilojoule per mole. Okay. Okay, so let's move to the next question. Now, see this. Now this question you have to tell me about a primitive lattice and the unit cell necessary has the following attributes. It has the one lattice point and the note the smallest repeatable unit, or it is the smallest repeatable unit and contain more than one lattice point, or primitive unit cell has larger volume than the non-primitive unit cell. And D option is the primitive unit cell could be of any shape. It has the multiple choice question. There will be the I mean more than one correct option. So you have to tell me about the which option will be the correct one for the primitive lattice and the unit cells. This question is so easy, so that you have to tell me. You know about the primitive lattice and the non-primitive lattice? There are the two kind of the lattice. One is the primitive one and another is the non-primitive one. Here it is asked about the primitive one. So which one will be the primitive lattice? Okay, so primitive has the only one lattice point. Non-primitive has more than one lattice point. So tell me now Which one is the correct option? Now, I have already told you about the primitive and the non-primitive, and they have asked about the primitive lattice. So, which one is the correct one? Is it having the one lattice point or more than one lattice point? One lattice point, more than one lattice point, and the primitive has the larger volume than the non-primitive, or the unit cell could be of any shape. Which one will be the correct answer? Option B. It is the smallest repeatable unit and contain more than one. Here it is more than one lattice point. More than one lattice point is in the non-primitive lattice point. So the correct one has the only one lattice point. There should be the only one lattice point. So which one will be the correct? A part. It has the one lattice point and it is not the smallest repeatable unit. It depends whether it will be the smallest repeatable unit or not. Now, primitive unit cell could be of any shape. Okay, if we have the lattice like this one, if I am considering, so the primitive unit cell, this can be a one unit cell. In the primitive, there is a condition it should be has a one lattice point only. So I'm choosing this one. Another one, you can choose this one. You had also the freedom, you can choose this one. So okay, this is also, and if somebody has chosen this one, I mean, let it be like, okay, this one. So these, it can be of any type. This one, this is also a primitive lattice point, and this is also a primitive lattice point. So is the shape defined here? No. This primitive unit cell can be of any shape. So the option D will be also correct. So it has two correct option. One, it contains the one lattice point, and the second one is the primitive unit cell could be of any shape. Okay. Okay. Let's move to the next question. Question number 13. Sorry, question number 13. So, which one of the following pair of atom is most likely to form an ionic bond? Nickel and fluorine, carbon and fluorine, and the nitrogen and the fluorine, and the oxygen and the fluorine. Which one will be most likely to form the ionic bond? Do you have any idea which option will be the correct one for the which one pair of the atoms will more likely to form the ionic bond? You know the condition required for the ionic bond? For the ionic bond, if there exist two atoms, let's say this is my A and B, two atoms are there, and the what kind of the bond, if they are existing the ionic bond, so what kind of the condition they have fulfilled for this ionic bond? They should have the high electronegative difference, high electronegative difference in the atoms of the elements or the atoms. Okay, so one should be the electropositive and other should be the electronegative. Okay, if you see, let's go to the periodic table one. This is my periodic table, and here if I see, now this is my periodic table, and these are my electronegative one. These are my electropositive, even though they are also electropositive one. So most likely they are for, so for the, now we, if we have to say one, if I'm A and B making the ionic bond, so A has to be the electropositive and B has to be the electronegative. Okay, so if A is the positive and the B is the negative ionic bond, because we have the only three bond in the covalent bond, they share the atoms, they share the electron. Basically that's depend upon the sharing. I mean, if I am having if let's say this carbon having the four valence electron, so another carbon also have the four, and the another four also, they will share and complete their outer orbit. That depend upon sharing of electron covalent. Metallic bond, third is the metallic bond. In the primary we have only three one. In metallic we have the, if because in metallic we have the free electrons, this is the more positive nucleus, and the free electrons are moving, they are just random moving, because these are the free, they don't uh, I mean share their electrons, they are the freely moving. Okay, N and F, yes, option A is correct, N and F. Because why N and F are the correct answer? Because see, my sodium is lying here and fluorine is lying. Electronegativity increases this side and decreases this side. Or increases this side. Okay, now this is also same for the electropositive, also decreasing this side, and they have the, this one are the higher. Now we have the, in the option we have sodium and the fluorine, carbon, nitrogen, sodium, carbon, nitrogen, and oxygen. We have this nitrogen, fluorine, carbon, nitrogen, oxygen. See, there should ion in ionic bond, they should have the high difference in electron. If I see, because they are having the less electronegativity difference in between C and F, rather than, because this is my sodium is the electropositive. This sodium has the one valence electron in the outer cell, and the fluorine has the one I mean in the outer cells they have the seven electron. To complete then it fluorine required the one valence electron, and sodium it can easily give to the fluorine and can make the electric bond. But here, because in this is neon and the 3s1, this is the 11 na? So 1 is to 2, 1 is to 1 is to 2 is to 2p6 and the 3s1. Yes, this is my neon, and the carbon having the 6 electron, they having the 4 in the uh, this 4 having the 2s2 and 2p6. But if I see in the fluorine case, fluorine and oxygen case, if I write down the nitrogen having the 7 atomic number, so it is having the configure 1s2, 2s2, 2p3. Oxygen is having 1s2, 2s2, 2p4. So to complete it oxide, it need how many electron? Because peak and orbital have the maximum 6 electrons. 4 electrons are needed here, 3 are needed here, and the 2 electron are needed here. And the fluorine only, fluorine having the 1s2, 2s2, 2p5, and fluorine need only 1 electron. Okay, it is having the, it need the 4 electron to complete. Carbon need the 3 electron to complete, and this 2 electron, and this is the 1 electron, and this sodium having the 1 electron, because this is electropositive, this can give the 1 electron easily. So it give the 1 electron to the fluorine, this one, and they can easily make the bond. And so that's why N and F are most likely to form the ionic bond. And if I see in the electronegativity of the all the elements, then we can also, wherever wherever we uh, wherever we can find the electronegativity difference between the atoms, we can they can form the highly ionic bond. So if I see the electronegative, I am representing with X. This is electronegative of the sodium is around the zero point 0.9. Fluorine having the highest electronegativity, this is around the 4. And this carbon and nitrogen and oxygen around having the around 3, I mean around 3.4 or 3.5. Because the carbon is coming this way. If I go to the this one periodic table, they carbon is having the less electronegativity than the nitrogen, oxygen and the fluorine one. Okay, so carbon is having around the 2 point something. Both these are having the 3 point something value, and the fluorine is the highest one. This is having the around the 4. So what the difference, the highest difference between will be in the sodium and the fluorine one. So this will make the ionic bond. Okay, so let's move to the next question, that is question number 14. Now, which one of the following is not true of the metallic bonding? Now, we already told you that the three kind of the bonding, that is ionic, covalent, and the metallic. Now, you have to tell me what is not true about the metallic bonding. First is it give rise to the excellent electrical conductivity. Electrons are free to move throughout the surface. The strength of the metallic bond increases as one move down a group in a periodic table, and the strength of the metallic bond affect the boiling point of the metals also. So which one is the correct? Metallic bonding, basically in the metal, as I also earlier told you, this is positive, and there are the lot of electrons that are freely moving in the material. So which one is not true? You have to tell about the which is not true about the metallic bonding. So which one is the correct option? See, this metallic bonding having the lot of free number of electrons. Okay, so because there of the lot of electron to move, so there will be the high electric conductivity, because electron can move easily, and when the electron move easily, then that can generate the current that will give the conductivity. So this metallic bonding having the excellent here, the high electrical conductivity. Now, in the next point, electrons are free to move throughout the surface. Yes, electrons are free here. They can move across the material in the metal, so they are the free to move throughout the surface. This is right about the metallic bond. But here we have to correct C option. Yes, the option will be the correct option will be the C1. And this C1, I will discuss you how the C1 is the correct. So next point is the strength of the metallic bonding affect the bonding point of the material. Yes, if somebody is having the free electron, because they are not tightly to the bind to the nucleus one. They are free now. They are free. They now they because in the metallic also, if I boiling point is basically we are water is boiling. What is the smell? This is means the my this liquid will transfer to the gas in the gas form. So boiling point temperature also depend upon the strength of the metallic bonding, how tightly they are bond in the in the metal. So that also, that's why the boiling point, because the bonding, we already tell you that the bonding lead to your high bonding, means high boiling point and high boiling temperature or high melting temperature. And the low, if low high bonding, this is the high bond energy or high bonding, same cheese, high bond energy or the high bonding. If similarly, because they need the higher energy just to remove the electron from their orbital. Low bonding or the weak bonding, same similarly. Weak bonding is low boiling temperature or the low melting temperature. Okay, so now this is the correct about the metallic. Now C part is the, now only remain with the C option. So this is not true about the metallic. Here the strength of the metallic bond increases as one move down a group in a periodic table. When you see the periodic table, you can see the size of the atoms here. If we move downward, the size of the atom is increasing. Now the my nucleus is keep growing, increasing, and now the we have the electron. See, we have the this one. Now if one atom is this one, and now this has the free electron like here, and another one is the this one, and the free electron in is here, something here. So which one? Because nucleus will be the here in center, na? Nucleus one, and outer one this for here, and here it is, and there is a lot of orbital here. As we go down, so number of electron will increases, and the now the this is having the here for this one, this is having this one, and here it is one. So which is having the higher one, higher metallic bond, because this has the shielding effect of the ore. So there will be the weak interaction in between this one. So metallic bond will be the metallic bond will decrease as we move downward. In case this here the metallic bond, because the metal, the bond existing in this one will be the high one. So as we go downward, size increases, size of the atom increases. So my metallic bond metallic bond strength decreases. So this is not correct about the metallic bond. So C is the correct answer. Okay. Okay, so do you have any doubt till this point? No? Okay, then let's move to the next question. Question number 15. So which among the following is the strongly directional in nature? One is the metallic, another is the covalent, and the this one is the ionic, and the van der Waals forces. Which one is the strongly directional in nature? Metallic, covalent, ionic, or the van der Waals one? Which one is the strongly directional one? Any idea? B, yes. The covalent bond are the strongly directional in the nature, while my ionic, metallic, and the ionic are non-directional and weak van der Waal also are non-directional in nature. Okay, so B is the correct answer. So, okay, so this is only about the assignment one. So, tell me about your doubts that you have in the assignment one or till the in the coursework also. If you have any kind of doubt, please let me know. Please feel free to ask any kind of the question, any doubt you are having. Is every question clear to you? We have done total 15 questions. All are clear to you? You can unmute yourself and can let me know. I mean, Ankit, I don't know. Is it your previous comment or the you have recently? Okay, no doubt. Okay, no doubt. Yes. Okay. And Pani Charan, do you have any doubt? Do you have any doubt in your course or as well in the assignment? You join late, and I mean, this video will be also available on the YouTube. We will share that a link also with you guys. You can go through it, and if you have any kind of doubt, you can ask in the next session as well also. And this section also, I can show you the all the question from the first one. Just Panicharan, you can tell me. I mean, this is the first question. If I have anything, I will mail you. Okay, that's great. I mean, no problem. Okay, just go through the if 15 questions, just have a look on that one, then so that I mean, understand. Do you was this okay? You have the this assignment PDF, I mean the question PDF or no? No, you don't have the okay, you don't have the assignment. So, okay, just have a look at least. I mean, take the question screenshot, and if you have any kind of doubt, then you can mail me. My mail will be visible to you. Otherwise, I am just dropping in the chat box. So this is my email ID. You can message, you can mail me that if you have any kind of doubt. Otherwise, we will discuss in the next session that we will have in the next Tuesday, same slot, 6 to 8 1. This is the first question. I'm just again going through it. This is the second question. If you can see, the first two questions are about the crystalline structure. Which one has having the characteristic and the crystalline? One is the crystalline and the non-crystalline, and their characteristic one. Okay, this one is the second one. And the third question is all about the which structure units are having the highest symmetry. That's the cubic, hexagonal, triconic, and the tetragonal one. And fourth question is regarding about the metal, polymer materials, characteristic of the polymeric materials, which compared to the metals. If I compare the characteristic of the metals and the polymer, which one is the characteristic property of the polymer compared to the metal? So polymer are having the higher elongation than the metal one. Okay, and the temperature, stability, mechanical strength, and the lower hardness is higher in the metal one. This is the fifth one. About the ceramic, you have to check the characteristic of the ceramic and find out the which one is the incorrect statement about the ceramic one. The sixth question is about the microstructure. We have the different four type of the structure here, and you have to find out the which of the option are comes under the microstructure. category. So four structure are the macro, micro, nano, and then atomic one. Macro, that is visible to our eyes, both, and the atomic we can't go to the atomic level. The micro and the nano we can go through the optical instrument, that is TEM and SEM. Uh, that are the instrument that from that one we can go up to the micro and the nano level atomic size. Okay, seventh question is about the at the equilibrium position. What about the condition at the equilibrium position when the my force is zero? That is my equilibrium position. This is my seventh, the equilibrium separation. So there, what condition is fulfilled? My net force will be zero, and my potential energy will also be the minimum. That you can see from here. This graph also. This is shown here. Okay. So next question is about the bond. About the coefficient of the thermal expansion. As I told, my thermal coefficient of thermal expansion is inversely proportional to delta T. So higher the thermal expansion, lower the bond. So this implies the weaker bond and the lower bond energy. Okay. So the next question is about the if we have the electron. Now you have to write the. Okay, so in this question you have the 6 electron in the d orbital of the transition matter. Bipin, can you please mute yourself? Bipin Kumar, can you mute yourself? Amen. Okay, I'm just mute. Okay, so in ninth question, we have the 6 electron in the d orbital, and you have to find out the number of unpaired electron. From the Pauli exclusion principle, we have filled the 6 electron, and because the 4 electrons are unfilled, these 4 are. So these 4 are, so there are the 4 number of unpaired electron. If somebody asks you how many of the pair, so this is the one orbital that is having the paired electron one. So the 10th question is all about the nickel electronic configuration, that you have to find out the electronic configuration, outer electronic configuration, because they haven't asked only the outer. Inner will be the, because the the inner orbital are completely full. There is they have only asked about the outer electronic configuration. So because nickel, they have also told about the copper electronic from the nickel atomic side, because for the electronic configuration you need the atomic number of the element. So from the copper electronic configuration you can find what is the atomic number of the copper, and because nickel is lying left to the copper one, because the nickel is having this outer one. So argon here also, that is having the 18 electron, 10 plus 1, this 28 and plus 29. So copper is having the 29 atomic number. So nickel is left to that one. So nickel is having the 28 atomic number. So basically the 28 electron. So you have to find out the outer electronic configuration for the nickel one. Okay. So next question is about the primary bond energy. So the primary bond having the energy range. In what energy range the primary bonds are lying? So they are lying in the 100 to the 1000 one. And then the next question they are about ask about the primitive lattice unit cells, because the primitive lattice having the one lattice point and the non-primitive having the more than one lattice point, and primitive lattice can be of the any type. So these two are the correct option. Okay, so question 13, they which of the pair of the atoms having the most likely to form the ionic bond? Whatever the atoms having the high difference between their electronegative, one should be the electropositive and another should be the electronegative. The pair having the higher electronegative difference, that will likely to form the most this ionic bond. So here the my sodium and the fluorine, well, having the larger ionic difference, this is electronegative difference, so they are most likely to form the this one, the ionic bond. If somebody has given this another option, lithium and the fluorine, because lithium has a more electropositive, so then your lithium and the fluorine are most likely more likely to form the ionic bond compared to the all above. Okay, so the next question is all about the metallic bond. So which is not true about the metallic bond? So if I say metallic bond are also excellent electrical conductivity, they are having the electron that are free to move throughout the surface, and the strength, if I'm going downward through the electro periodic table, so the strength is going decreasing downward, and also toward the right, also right of the periodic table also. And strength of the metallic bonding also affect the bonding point. Higher the metallic bonding, higher the boiling point or the melting point as well. Not only the boiling point, it also affect the melting point also. So these are the directly proportional. Higher strength, higher melting point, higher boiling point. Low strength, lower melting point, lower boiling point. So the next question is which bond is the strongly uh, directional in nature? So your metallic, ionic, and van der Waals are the non-directional in nature. They don't have any direction. So the covalent are the strongly directional in the nature. So this is all about the assignment one. We have covered this one. So now, I mean, you can ask any question. I'm just now, Bipin, Panicharan and the Ankit, if you have any kind of doubts, please let me know for this session. No, ma'am. Okay, thank you, Ankit. Panicharan, do you have any doubt, Anu? Panicharan, Bipin Kumar, can you hear me? Yes. Okay. Just unmute yourself and you can ask the question, Bipin Kumar. Uh, please unmute yourself, Bipin Kumar. Please unmute yourself. Yes. Yes, ma'am. Yes, sir. What's your doubt? Sorry, I can't hear you. Can you repeat again? क्या क्लास नहीं ले चुका क्या नहीं ले चुके हो अच्छा तो डू यू हैव एनी डाउट्स इन कौन से वाले क्वेश्चन में तुम्हें डाउट्स है दिस वीडियो इज अवेलेबल ऑन द यूट्यूब so you can go through it and you if you have any doubt and you can check in the chat box I have dropped my mail you can ask in the on the mail also and otherwise we will discuss in the next session okay and the Panichar, where is the this assignment PDF available? Is it? I don't know. This may be available to you. Video link. For my side, we have to upload the link somewhere. I don't know. This will be available to you. I will submit this one to a folder, and maybe then it will be available to you. Okay. Otherwise, I will share this in the next session. Most likely this will be the visible to you. I will share in the folder and that link will be the available to you. And you can go through that one. And this assignment PDF, isn't it available to the course where you can see the course? No, okay, okay. You can take the screenshot of this, I mean the all the question and if it is not, I mean you can take the screenshot and then later we can discuss if you have any kind of doubt. I can go through the again the all the question and you can take the screenshot and so that you can go through the at least assignment once. Should I go with it? I mean, should I go from the first one or are you you have okay, okay, that's great. I mean, okay, okay, fine, fine. Okay, then if you don't have any doubt, then you can leave the meeting. I mean, okay, you great, you have done. I mean, otherwise, I will share the this video link in the folder. Maybe that will be visible to you after meeting this after this meeting over. I mean, in the this week, I mean this week you will get this thing, this link. That link will be available to you, and also this link also will be uploaded on the YouTube also. From there also you can upload, you can check the assignment. This one. Any other doubt? I mean, if you don't have, then you can leave the meeting. We can discuss anything if you have any kind of question. Okay, thank you. Okay, yes, I'm just speaking. You can leave the meeting. If you don't have any doubt, you can leave the meeting. No problem. Because the class from 6 to 8. We can discuss anything. I mean, if any question if you want till 8, we have the 10-minute remaining. I mean, in that time we can discuss. This meeting. Okay. Ankit, if you want, we can discuss. Okay, you have already left the meeting. Okay.